Hello, welcome to Unified Science Lab. Today we are going to solve an example on the analog circuit, and the question is here. This is a question: calculate the current flowing through C, current flowing through B, and current flowing through E, and also calculate the potential point C, B, E, as well as D and A. This potential point means the voltage flowing through the points C, B, E, D, and A. That's the meaning of this potential point, is the voltage flowing through that point. So coming back to this circuit, we have it comprised of the ground, the input voltage, the switch, the resistor, there is the RB, RC, the diode, and the NPN transistor. So first of all, we are going to find the current flowing through the points C, that's IC. They have given here the resistance B. This resistance B, they have given it to be 100 kilo ohms. They have given RB to be 100 kilo ohms, RC to be 220 ohms, and the beta to be 100. And this is the formula for IC maximum. Note, IC maximum is different from IC. The maximum current flowing through IC is different from the normal current flowing through IC. It has a different formula. So let's go into solving. First of all, we will solve for the current flowing through IB. This is the formula to solve that one, the current flowing through IB, which is IB is equals to change in voltage all over RB, which is the same as the supply voltage is here. Note, this VCC, let me write VCC, this supply voltage is the same as this, because the same voltage flowing here is the same voltage as at VA, at this point A. So you can write VCC, or you can, in place of this VCC, you can write VA, you understand, minus VBE. And VBE is given there to be, is given here to be 0.6 divided by RB. So the current stream flowing through point B is 12 minus 0.6 divided by RB, and RB is given there to be this 100 kilo ohms, which is 100 times 10 raised to power 3. Kilo is 10 raised to power 3. That's why I write it that way. So do your normal calculation here, IB, and divide it with this. IB will be equals to 0.114 milliamp. I convert it to milliamp at once. I don't want to waste your time going through that. To do normal calculation by the subtraction and the division is very simple. That's why I don't want to waste much of your time there. You know the steps. I just give you the formula. It's very simple. Now, after solving for IB, the current flowing through point B, then let's solve for current flowing through point C, and that will be C, and the formula is different. It's not the same formula that is being given. If you check this circuit, they are not the same. They are not in the same place. It's not a straight line. It's not it's in series. It's not in parallels. Rather, just there is not only resistors. Other components are inside. For example, this diode and the NPN transistor. So they have different formula to solve them. So the formula to solve this IC is given as the beta multiplied by IB, and IB, we just solve the IB is given here. So IC will be equals to beta was given to be 100. If you check here, beta was given to be 100, which is 100 times, and IB, we just solve IB now, which is 0.114, which will give us 11.4 milliamp. Please don't forget your unit. If I did not put milliamp, or if I put amp, the answer won't be correct, because I'm using milliamp. If I mistakenly put amp here without using this milli, the answer will not be correct. So your unit is very, very important. Don't forget to put unit whenever you are solving. Now we have solved for the current flowing through point B and C. So let's go into the current flowing through point E, which is this point E. That's the current. Note, current flowing through here, this point E, is different from the voltage flowing through point E rather. We will also solve for that, so that you know there are two different things. So the current flowing through point E, which is IE, is equals to IC plus IB. This IC plus IB gives us the current that flows through this point, which will be I is equals to, the IC was solved and is here given to be 11.4 milliamp times the IB was solved here, which is 0.114 milliamp, which is equals to 11.514 milliamp. So we have finished solving for the current flowing through each point. Now let's go into the voltage, because the answer did not stop here. It also says, and also calculate the potential points C, B, E, as well as D and A. So let's go into solving the potential points. As you can see, it's very simple, but if you don't understand the question, it will take you a long way. And if you don't know the formula, you have to master the formulas, especially in engineering. We are dealing with formulas. If you know the formula, the calculation will be very easy for you. And also you can run this if you have an app like Multisim or every circuit or Voltsim. You can run this, you can connect this using Multisim and see the value that it will give you. If it corresponds, it will likely correspond. I have tried it before solving it here. I've tried it with using every circuit, and the answer was given to be this. And you can also try it. You can even use Multisim or Voltsim. It's an app which used to stimulate a circuit. So moving to solve this voltage. Solving the voltage, I think we should start with D. Of course, we know A already, because I told you already A. The voltage flowing through A is the same voltage at this. So let me just write it. VA is equals to the voltage that flows here is the same voltage at this point. It's equals to 12 volts. So solving for solving for VD, the voltage flowing through point D, because that is under the question. Voltage flowing through point D, that will be A minus the voltage VA minus the VC, and VA minus VC. You can calculate for VC by saying VC from Ohm's law. Ohm's law states that V is equals to IR. So looking for the voltage that flows through this point C, we already have the current flowing through point C. Where is it? We already have the current flowing through point C to be this, and we also have the resistance flowing through point C. The resistance flowing through point C was being given here. So solving the currents and solving the voltage flowing through point C, VC is equals to IC multiplied by RC. So these two values are being given. So VC will be equals to 0.0 0.00114 multiplied by the resistance given. There was 220. And if you multiply these two very well, that means Vc will be equals to 2.508. That's the Vc, 2.5. Let me put the unit volts. And I just noticed something. Many people may be confused with this value that I just put in here. Please don't be confused. I convert from milliamp to amp. It was given, I convert this one to milliamp so that I can use it and solve this one. I converted everything to milliamp. The IC that I solved there, I converted to milliamp. So converting it, okay, let me convert it back. It was this is it, 11.4 milliamp. So if I want to convert it to amp, I will just multiply it by 1000 times 1000, and it will give me 0.0114. Please don't be confused. Amp. It's still the same answer, but the unit changes. Like I convert it. That's why I put it here. Please don't be confused. I convert it back to amp, from milliamp back to amp, because I want to calculate it with resistance that flows through there. So we have getting the Vc. We know what Vc is. We know what Va is. Now we can solve for Vd, which Vd is Va minus Vc, which is Vd. Is equals to Va that was given there is 12. I told you the current, the input current is the same current that flows through the point A. 12 minus 2.508 volts, and Vd is equals to 9.492. That's the answer for Vd. And moving forward, we know what Va, Vd, Vd and Vc. We know what Va, Vd, what is Va, Vd, and V, which other V, Vc. We know them, but the only value that I did not explain is Vb and Ve. Note, VCE, rather VBE, is equals to VB minus VE. I would have explained this earlier, but it's still okay. This current, this voltage VBE that was given somewhere here, that was given here to be 0.6, is the same voltage that is flowing through the point B. VBE is equals to VB. It's the same voltage that flowing through this point B. So since it's the same voltage, this one will be 0, because 0.6 minus 0 is equals to 0.6, which is this. This one is this, this one is this, this one is this. So VE is equals to 0. Then VB is equals to 0.6 volts. I think that's all. We know what VC is from the formulas. Just know the formulas. Apply is very simple. VB, VE, which is 0, VD, which is 9.492, and which other V? VA, we know what VA is. And okay, after solving that, I think it's right to know the current that is flowing through here. We should know what these two means here. The current flowing through here, because the voltage flowing through here. Any voltage that passes through a diode, the diode always drop the voltage. Like some diode it's rated 0 is 1 point something to 3.5. So this 2 means the voltage that passes through this diode, it would drop. The voltage will drop by 2. Like the voltage at this point D is 9 points. Voltage at point D is 9.492. So voltage from this point passing through this diode to this point will be -2. This 2 here, and it will give us 7.492. So that's how to know the voltage at this point, not at E, because voltage at E is equal to 0. The voltage at this point, the voltage going back, it was from here. You calculate this plus this gives this, so there's no other this thing again. From here up, from here down, there's no other voltage that is running. It's only the current that E has a normal value, but if the voltage is 0 at point E. So the current at this point, at point PCE, is equals to 7.492. Thank you for watching, and if you don't understand, you can just tell me in the comment section. I'll explain more, and you can even